Welcome to Pharma Drama, the channel where we look at the science of healthcare and healthcare products. Today we're going to look at a key concept in understanding and reporting data, central tendency, in particular mean, median and mode. I wonder what a good acronym would be for mean, median and mode. We make measurements of things in the laboratory because we want to understand something about our sample. For instance, do the capsules in a batch have the same fill weight? Or does each tablet in a packet release drug at the same rate? So we design an experiment, do it, and then record the outcome. We don't normally do an experiment just once because there's always an amount of uncertainty in making measurements. So to try and account for that, we make measurements a number of times and look to see how much variability or spread there is in the data. We could, of course, simply look at the data and make a judgment by eye, but it's much better to try and quantify the variability in some way. We do that in two ways. One, by determining the central tendency, and two, by assessing the degree of variability or spread. Variability is reported with a standard deviation, and I won't look at that here. Funnily enough, there's a separate video for that, the link for which is in the description below. Here we are considering central tendency. And what does that actually mean? Well, imagine that we have repeated our experiment a number of times. And I should note here, most students consider 3 repeats of something as going above and beyond. But I think triplicate measurements should be the minimum you should consider, and really you need more. If you want to know why, you need to understand frequency distributions. And yes, there's a video on that too. We will have a set of data with similar but slightly different values, and we need a way to report a single value. We do that by determining the central value around which the data vary. That can be done in several ways, which we'll look at in turn. First though, we need some data, and for that I shall turn to my trusty packet of ibuprofen tablets. Each tablet should contain 200 milligrams of ibuprofen. We know that because it says so on the packet. So imagine we want to test that, and we take 15 tablets, dissolve them in water and determine how much drug is present in each. We would have 15 data points, just like these. Looking at these data though, it's quite hard to determine what the central tendency is. But if we rearrange them in increasing numerical order, like this, things become a lot clearer. The easiest way to report the central value is to look for the central value. There are 15 data points, so therefore point number 8 is the central value, which in this case is 200 milligrams. We call the central value the median. So if you see someone reporting a median value, now you know what they've done. They've lined up their data in numerical order and taken the middle value. Another thing we can do is look for the most frequently occurring value. Whenever we make repeat measurements, we will find we measure particular values multiple times. We call this a frequency. The more times we record a particular value, the more frequent it is. When we plot data as a function of frequency, we get a distribution curve. I mentioned that earlier, and we're not looking at them here, but they are very important, trust me. We usually find that the most frequently occurring value is also the central value, and we call that the mode. So, if we look at our data and see what the most frequently occurring value is, we can report that as a mode. In our case, we find there are actually 2 most frequently occurring values, 199 and 202 milligrams, so we would say our data are bimodal. I think you might imagine that median and mode work best when applied to larger data sets. so we don't use them very often in the lab. Neither is particularly helpful when there are only 3 data points. The median will always be the middle value, for instance. Instead, we use another value which is termed the mean or average. The mean is calculated with this scary looking equation. But fear not, it's not that bad. It just has some funny mathematical symbols in. Mean is given the symbol mu, which is the letter M in the Greek alphabet. The equation simply says that the mean is calculated by adding all the data points together and dividing by the number of data points. So in our case, we would add up all the data points and divide by 15. If we do that, we get a mean of 200.2 milligrams. The mean is a much better choice for the type of data we normally record in the pharmaceutical world, because it automatically accounts for the frequency with which specific values occur. It can also be applied, if you really must, to data recorded in triplicate. You will notice that in the case of the data I am using, the median is 200 milligrams, the mean is 200.2 milligrams, and the modes are 199 and 202 milligrams. So, the values are similar but different, and it's important to know what they mean. And now you do. I would also note that when recording data, if you know what the true or expected value of the measurement should be, in this case 200 milligrams, then how close the central value is to the true answer is a measure of accuracy. It's a common misconception to say that measurements have been made with precision if they give a value close to the true answer, but that is wrong. Precision relates to the spread in the data, as you can see me explain in another video. And that is all we need to know about central tendency. I hope that made sense. To interpret data properly, you really also need to determine variance, and that is done with standard deviation, which I look at in a separate video. Link below. If you found this video helpful, please don't be mean and consider hitting the like button. And, even better, subscribing. It really helps the channel. Otherwise, thank you so much for watching, and I'll see you again soon.